Hello everyone. Now in radiation we will see electrical network analogy for thermal radiation system. It is an alternate approach for analysis of radiation heat exchange between gray or black surfaces. It is an alternative for to determine the radiation heat exchange between the bodies. Now we need to see what is irradiation and radiosity. Irradiation, the total radiation incident upon a surface per unit time per unit area, which is incident upon a surface per unit time per unit area. Next, radiosity, the total radiation leaving the surface. Radiosity is the total radiation leaving the surface per unit time per unit area. Irradiation is incident upon the surface per unit time per unit area, and J, that radiosity which is leaving, is equal to its own emissive power plus rho into G, where rho is reflectivity, Gr by G, and G is the total irradiation. So this is what the total radiation leaving the surface, reflectivity into irradiation plus emissive power. So radiation is equals to epsilon into Eb plus rho G. Emissive power is equals to epsilon into Eb plus rho into G. And we know that alpha plus rho plus tau is equals to 1. Here if it is an opaque body, tau is 0, then alpha plus rho is equals to 1. Rho is equals to 1 minus alpha. Now substitute rho as 1 minus alpha into G, and we get epsilon Eb plus 1 minus epsilon into G. Alpha equal to epsilon from Kirchhoff's law, and substitute alpha with epsilon, and J is equals to epsilon Eb J equal to epsilon Eb plus 1 minus epsilon into G, and you just take that term to the left, and we get G, that irradiation incident on the surface, is given by J minus, that radiosity minus epsilon Eb by 1 minus epsilon. We know the energy emitting or emissive power Q by A is Q by A. Emissive power, the rate of energy that is leaving per unit area, emitting per unit area, Q by A, which is equals to J minus G. J minus G. Radiosity minus irradiation. Incident radiation, we need to subtract incident radiation from the radiosity, then we get energy that is emitting from the surface. So Q by A is equals to J minus epsilon B from the equation 1. Substitute G, and we get Q is equals to we are going to bring a form that Eb, emissive power of black body, minus radiosity by 1 minus epsilon by AE. So this relation will give a conclusion. Let us see. There are two nodes, and we have a resistor in between the two nodes, say that is Eb, emissive power of a black body, J is the radiosity, and it is compared like this. Electrical analogy, Q net is equals to Eb minus J by 1 minus epsilon by AE, where 1 minus epsilon by AE is the surface resistance, like our thermal resistance. This 1 minus epsilon by AE is considered as the surface resistance. If two surfaces are emitting energy and exchanging energy, then Q122 is given with, there are two surfaces, they are emitting energy and they are absorbing, exchanging energy. If it is like that, then we can write J1 A1 F12 minus J2 A2 F22. That is from reciprocity theorem. We know that A1 F122 equal to A2 F221. So when you substitute that, again you can take A1 F122 common, and it is J1 minus J2. Q122 is J1 minus J2 by 1 by A1 F122. 1 by AF1 is called as space resistance. Here 1 minus epsilon by AE is surface resistance, 1 by A1 F122, because it is in terms of the radiosity, so it is a space resistance. In the space, if any obstacles are there, or because of the space, we will find some resistance on our earth. If it is vacuum, there may be no resistance, the space resistance, but and it is given 1 by AF. If two bodies are connected like this and you have EB1, J1, J2, EB2, msu power, radiosity msu power. So, between msu power and radiosity between the single body, that is 1 minus epsilon 1 by A1 E1. Between two radiosities J1 and J2, you have 1 by that space resistance, here surface resistance, space resistance. So, both we need to adapt here. In between J1 and J2, it is 1 by A1 F122. In between J2 and EB22, 1 minus epsilon 2 by A2 epsilon 2. Now, what is the radiation exchange between the two bodies? That is given by Q122 net is given by EB1 minus EB2 by that sum of all the resistances, that's it, R1 plus R2 plus R3, the surface resistance, space resistance and surface resistance. When you add up all these things, we get a final relation, and after all assumptions, saying we get an equation sigma A1 T1 power 4 minus T2 power 4, because substitute this mzu power, we know that it is sigma into T1 power 4 minus T2 power 4 per unit area, and so even you just take A1 common. When you take A1 common, that can be taken above. So, sigma A1 T1 power 4 minus T2 power 4 by 1 minus epsilon 1 by epsilon 1 plus 1 by F122 plus 1 minus epsilon 2 by epsilon 2 A1 by A2. So, if A1 is equals to A2, F122 is 1, shape factor is 1, then the final relation can be reduced to Q122 equal to sigma A1 T1 power 4 minus T2 power 4 by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. So, the equations, again we are getting the same equations. Now, even though it is a electrical analogy, a different method of approach to find a radiation heat exchange between two bodies, you have got the same equation. Just go through the previous notes, in that you will find the same expressions. I have given one table 1, 2, 3, 4, 5 till different interchange factors and shape factors I have given. In that you will find the same expression here. You just compare these two, you will get.